Okay, for some while, I should apologise for my voice, I've got a cold. I've been interested in our Telepresence project. You may have seen the wacky devices that cost lots of money, and maybe some homemade mock-ups, but the top of the range ones are on a two-wheel caddy thing here, and there's a stalk and often a tablet PC there, or iPad, something like that. This runs Skype, this is mobile through the internet, and it can walk around, and the idea is a person can be present without being present through the miracle of a camera and a screen and some way of moving around. So that was the idea. Sticking with the idea of using a mobile phone or a tablet for all the video and audio, we're just left with the buggy, which is a way of moving around. The obvious lowbrow way to do that is have a cart that's got two wheels and put some electronics on there and have a couple of motors that drive the wheels clockwise or anti-clockwise, so the thing can rotate on its axis, move forwards or backwards in this kind of a way, and then you set your tablet on there some way. So then it comes down to, how do you control something like this through the internet? So this can be anywhere on the planet, and you, the person who wants to teleport or telepresence themselves to the remote location, can exert control over the device through the internet. Well, that's the first challenge I decided to solve. The first thing I decided is that I'd need some kind of a joystick interface. So you may have seen the virtual joysticks where you just touch the screen anywhere and a circle appears, and then when you drag your finger to the left or right, up or down, the inner circle moves around to show you where you've put the joystick, and the outer circle remains where it was to show you where home base is. So this can generate a series of commands. Now, I managed to pinch a piece of JavaScript from the internet. Well, it was freely available. No crimes were committed. And this just gives an XY coordinate where this is -255 in the up direction, this is 255 in the down direction, 255 and -255 in that direction. So you get four numbers out of the device, out of the JavaScript code, and I decided to put these up onto the internet into an SQL database table. I've got one of these H controllers, so the way they work is you put a motor just there. If you drive current this way and out that way, the motor will spin in that direction, and if you drive current this way and that way, then the motor will spin in the other direction to the one I just drew, whichever one that was. So that's a motor controller, and then there's an enable pulse, which you can pulse width modulate. So if you want to go forward, you send this high, this low, and you pulse width modulate to show where you how hard you want the motor to work. And if you want to go the other way, then you set this high, this low, and again there's another pulse width modulation signal that comes in here, so you modulate it that way. So I encapsulated these numbers, one record in one table, 1, 2, 3, 4, 5, 6, 7, motor 1, A, B and E, motor 1, and motor 2, A, B and E. So A and B are digital, and E is pulse width modulation for both of them. And there's one more bit called the X bit, which is just for frame synchronization, which I'll talk a bit more about later on, or maybe even not. So the idea is this piece of JavaScript picks up a joystick position and sends it and stores it into record 1. I've called pilot, record 1, and that's stored there. So that gets around the send data up to the internet. Now we need to look at how to get data down from the internet, so I'll look at that next. So we've got the data up from the joystick controller through the mechanism we talked about earlier into these 6 fields in an SQL database running on my server, which is accessible from anywhere in the world if you've got access permissions. And now we need to get it down to our little vehicle. That's a two-step process. I'm using an Android device. I'll signify it as a tablet, like that. Not sure how the little Android man goes, but anyway, there he is. So I've written an Android app, and what it does is go up to the server and extract that record, and then it's got Bluetooth, which accesses a little Bluetooth device on my robot, which goes into an Arduino, which goes to two motors, which goes to the wheels. And the tablet is physically attached to the motor, so the motor assembly. So when the Telepresence Robot runs around, you run around with it. Your face is on the front, and you can look out the camera at what the robot's seeing. So that's the theory, really. Step 1 is to upload. Step 2 is to download, and step 3 is to Bluetooth to the device. So much for theory. Let's look at the practical way I implemented that. Okay, so here's the contraption. It's exceptionally well made, as you can see. These are two motors from eBay with a gearbox included. Made these brass attachments here. Made the wheels from recycled milk bottles, and the tyres are cycle inner tubes glued on. So the two wires feed up through the bottom and into the motor controller. So the motor controller sends signals to drive the motors. This is an Arduino, which is driven by which drives the motor controller. So the A, B, and E for both motors, 6 signals, goes to the controllers. And this is the Bluetooth module. These are really good. They look like a serial line from the Arduino's viewpoint, and they communicate with the phone in that same way. So there's a cart, and it's driven by a lead acid battery, which is regulated actually through the motor controller, so that gives us a convenient 5 volts for the Arduino and for the Bluetooth device. So let's have a look at the code for that. Actually, first let's look at the joystick code. The only really interesting part is the virtual joystick, which is offline in a virtual joystick.js JavaScript file. That does all the magic. It's not that magical actually, but anyway, I get some numbers and I upload them to my website at this URL here, simply appending the X and the Y as get parameters to the URL. That's very straightforward, and when you look at that in a web browser, this is the interface. It's pretty much a blank screen, but when you press down with the mouse you get the joystick I was talking about, and when you move to the right or the left, the inner circle moves showing you where the joystick is, and you can see above where it says results that these are the numbers which are being sent to the database. Okay, so now we'll have a look at the JavaScript code, the Android code. This is pretty massive, but most of it's redundant. It comes from another project I've worked on, which is my allotment surveillance system. So pretty much the only thing of interest here is that it opens an internet connection. Well, actually, it opens a Bluetooth connection first to the module. If it can't do that, it doesn't do anything else. If it can open a Bluetooth connection to the module, that module there, then it goes ahead and reads from the database and writes out to the module. So it's always reading from the database and writing out to the module. And because there's another page in here which has got a couple of modes, in dump mode here, all it's doing is reading from the database that single record, and repeatedly it's doing some formatting, outputting that single record to the phone. So as far as the phone is concerned, because the connection at the socket's never closed, the phone is reading a very long file of numbers, of integers. But actually that very long file of numbers is being constantly topped up by the joystick application. So this joystick program here is ramming in numbers into that database table, and this code is dragging them out again and spraying them down the line to the Arduino. That's how we implement that three-step process there. So let's have a little look at how it works. So the first thing I'll do is hook the battery up, very straightforwardly. Where are we? Yeah, there we go. So we see the Arduino's on, and we see the module, if you can see that, has a red light flashing. What that means is the module's working and it's interested, but it's not connected to anything. So now we run the application on the mobile phone. Let me show you that. So it's in here. It's called, for weird reasons, an unusual thing, we should watch the, there you go, you can see the light's gone solid now. So we put the phone on the device, and it would be, you'd fire Skype up on this. At the moment that program doesn't run as a service, so if I try and go to the home screen and run Skype, the connection will die and it won't work. But even now the phone is reading from the internet those values from the table. So let's see if I can get both in shot here. I don't think I can. Well, I'll tell you what I'll do. I'll do one at a time. I'll click the menu and you'll hear a noise. That noise is the pulse width modulation coming on the robot. I deliberately haven't suppressed that with capacitors because it's, for reasons which will become clear, it's very useful to be able to hear that. You can sort of get a sense of what the system's about to do. So I'll just nudge it up a bit further, and the robot moves forwards. Now I'll move it backwards. So the first thing you can see is that the wheels are not very balanced, and in fact the thing is a real pig to drive, and it's sluggish as well. But you know, let's understand that what this is doing is fairly miraculous, albeit that it's doing it badly. Let's try and spin the thing round. Ooh, baby. But it's working. Anyway, the last step, I suppose, is to get the Skype element working. So let's do that. Well, for now I've just dumped my tablet, Android tablet, on the carriage like this. It's not running the Bluetooth connectivity out. That's still running on this phone here, for the reason I mentioned earlier about it not running as a service. So here's the system actually in use. I'll just dial myself on it. Okay, so this is the view of the Telepresence Robot, and I can move the Telepresence Robot by using this interface here. So swing it round to look at me, perhaps. It is a terrifying prospect, I admit. Ooh. And now over here. Note that the robot's not connected to anything physical. It's all done through Wi-Fi and the mobile phone network. And let's remember, this robot could be anywhere on the planet that's got some kind of an internet service. So although this looks fairly mundane, it is pretty amazing. As you can see, the skid is not very skiddy. It's a piece of fencing wire, so it's actually pretty grim. Wee. Come on, my beauty. Come back to daddy. No, I don't know why. I'm trying to get it to move and it's not. Oh, there it is. So now you can see it moving around. So that's me. So normally in telepresence mode I'll be saying, "Hello Frank, how are you?" And you'd be saying, "I'm fine, Chris, you dork. Why don't you come to work?" Anyway, improvements for the future. Well, these skids, these bits of wire, are because these things, casters, were absolutely useless. Wilkinson's finest. The user interface is sluggish for the steering. It's, as I say, it's really a pig. I've tried putting in a trim factor for the wheels to overcome the imbalance in the motor's torque and performance, but it's not really good enough. So the way to go, I suppose, is either some kind of optical wheel counting rotary encoder arrangement or stepper motors. I don't know if I'll bother or not, but it's been good fun and I hope you've enjoyed it. Like and subscribe and all that jazz if you fancy it.